Hello everyone. Today we're going to be doing another October-November 2024 paper, and this is paper 12 and this is question 34. So it tells us there's a current of 12 amps and there's a wire of length 0.35 meters, and we're given the drift speed, so we already know the formula, and we need to calculate the number of free electrons in the wire. So let's just write down our formula first. We know the current is equal to the cross-sectional area. I'll just label these out because this will really help. Cross area, and this is measured in meters squared. Then we have N, which is free number of free electrons per meter cubed. Then we have charge of the carrier, of course, and then you have the V, the drift speed of charge carriers, right? And that's in meters per second, and this is in it's a charge in coulombs, right? So what can we firstly deduce over here? So we know the value of I, this is 12. This is equal to An. We don't know the values of these, right? And this is equal to Q. We know Q is 1.6 times 10 to the minus 19 for all electrons. This is just 1 times the quantitative charge, right? And then we have 5 times 10 to the minus 4. And then if you calculate all of this, you should be getting the value of 1.5 times 10 to the 23 is equal to An. Now let's just process what An means. N, if you write out the units, we know area is meters squared, and we know that N is the amount of free electrons for volume, right? So if we times that, because this is per volume, number of electrons from the total volume, right? So if we do this, if we do this, we'll find out that just give me a second, I'll just quickly rewrite this over here. This is the cross-sectional area, this is meters squared, right? And then we have the volume per meter cubed, right? So when we're doing this, when we times this, we're getting basically the number of free electrons per unit length, right? We get the number of free electrons per unit length. Yeah, and if we do this over here, so this is per unit of per unit volume, we'll notice that this turns into 1 over meter. So this is per unit length, right? So this basically means there's 1.5 times 10 to the power 23 free electrons per unit length. Now, some people might choose C over here, but this would be an incorrect trap option, right? What we also need to do after this is it times it by 0.35. So if I do 1.5 times 10 to the 23 times 0.35, we get 5.25 times 10 to the power 25, and this basically rounds up to option B, which will be our correct answer over here.